Hello, this is Unit 4, Day 4, Notes. We'll be looking at using the calculator a little bit more, specifically to find real zeros and further analyze polynomial functions. And we'll do a little bit of a review on factoring quadratic equations to get you guys ready for factoring polynomials, specifically cubics and quartics. All right, so we've got the calculator pulled up. If you don't have a calculator out, you should get it at least to practice and follow along. So pause the video and get your calculator if you don't have it out yet. Okay, so let's go ahead and plug in this first example and take a look at this function and see what we have. So remember, for the negative sign, you use the first negative sign should be the negative sign next to the period at the bottom. Okay, for factors, I suggest using parentheses, especially older calculators. Not factors, excuse me, fractions. For fractions, use parentheses. So negative 1/7 x, and you don't have to use a caret. You can do math, and then the third option. So that's cubed, minus 2/3 x squared plus 3/2 x plus 5. Okay, now you may say, Mr. Hilliard, why are all these crazy fractions in here? It's really annoying to type in. Well, I'm sorry, but if they were bigger numbers, it wouldn't fit nicely on the screen. That's the best answer I can give you. So make sure you got it typed in correctly and go ahead and hit graph. Okay, if your graph does not look like mine, it's all zoomed out, funny, perhaps from doing all the other stuff we've been doing, press the zoom button and then hit standard. That's option 6. All right, so that is our graph of this function. Okay, just looking at it, think about what degree this is and what we've done so far. This has 2 turns, so it should be a 3rd degree. All right, so let's keep that in mind as we go forward. So the first thing we're going to look at is estimate in between which integers the zeros will lie. All right, well, Mr. Hilliard, we could just find the zeros, couldn't we? Yes, you could. But it wouldn't hurt just to go ahead and look and see and estimate where they're going to be before we go ahead. Like when you started learning how to do fractions and doing decimals or with square roots and kind of estimating those, it's the same idea. You want to make sure everything is consistent as you move forward. All right, so this first zero to the left, negative 1, 2, 3, 4, 5, 6. All right, so there's a 0 here between negative 6 and negative 5. All right, let's write that a little differently. That could be confusing. So negative 6 and negative 5. That's the first 2. That second 0 looks really close to negative 2. Okay, but let's say it's in between negative 2 and negative 1. Okay, and that last one looks right on positive 3. All right, but again, let's just assume that's not quite 3. So it's in between positive 2 and positive 3. Okay, just be able to look at the graph without doing anything else and kind of see where they're going to be and then move forward with the rest of our analysis. All right, so now let's actually find the real zeros. So remember, we're doing second calc 0. If you feel comfortable with this, you can pause the video and try these and check your answers. There's another practice after this one. So remember, we're doing left bound, enter, right bound, enter. Press enter a 3rd time. Your 0 is, if you round to the hundredths, that's negative 5.41. Okay, and now we're doing zeros, not x-intercepts. So you just write the x value. You don't write the point. Okay, let's find the next one. Left bound for this 0. Right bound, enter. Okay, so we were correct. It's a little bit less than negative 2. negative 2.197. So we'll call that negative 2.20. All right. And then the last one. Left bound, enter. Right bound, enter. Enter again. So this one is 2.942, so we'll round it to 2.94. Those are your three real zeros. Okay? So write those as x-intercepts. Write them as a point, so that's negative 5.41, comma 0. Whoops. Negative 5.41, comma 0. Negative 2.20, comma 0. And let's make a little more room here. .940. All right, those are your x-intercepts. So, number of distinct real roots. Again, all this is really asking is how many x-intercepts are there? How many x-intercepts are there? There are 3. Okay. Total number of real roots. Well, we shouldn't have to look at the graph for this. And again, we looked at the turns. Well, of course, you knew it was a cubic, right? Because it was this. But looking at the number of turns should confirm that. Confirm that we put it in the calculator, right? Okay. So that x cubed up here should tell us the number of total roots. Okay, which is 3. Okay, remember, total roots and total real roots are different, remember, because total roots could combine real with imaginary. So total real roots come from the x-intercepts, including multiplicity. Well, each of the multiplicities are just 1. Okay, so your total real roots are 3. If there's 3 total roots, and there's 3 real roots, there cannot be any imaginary roots. Okay? All right. Y-intercept. Okay? You could look at the function to do this. You could also plug it in the calculator. Remember, the y-intercept is when x equals 0. So we go to the calculator and do second, calc, value, type in 0 for x, press enter. The y-intercept is, remember, a point, so write it as 0, comma 5. Okay? All right, local and relative max and mins. All right, look at how we're writing this. This is the y value first at an x value. All right, so we're doing second calc minimum to start. So that means we're doing this one to the left. So do a little bit to the left of that point, enter. A little bit to the right, enter. Enter again. Your relative, I wrote this wrong. Okay, so we're doing the minimum first over here to the right. Sorry about that. So y equals negative 2.52 when x equals negative 3.988. So negative 3.99. Okay. Now the relative max, second calc, second calc maximum. Okay. Left bound, enter. Right bound, enter. Enter again for our max. The y value is 5.7. We'll call it 5.71 if we're rounding to the 100th. When x equals 0.8775, so 0.88. Okay, so this is using the calculator to solve and further analyze a function for something that you wouldn't be able to factor otherwise, or otherwise solve by hand. So go ahead to the next question below and try that on your own, and I'll have the answers when you come back. All right, so let's take a look at this one. Two real zeros. So their multiplicities are each 1, so they count as, I did this wrong. Here, there's 2 total real zeros. This is 4th degree, so there's going to be 4 total roots, real plus imaginary. So if there's 2 real, that means there should be 2 imaginary, okay, which you would be able to find if we were able to break this down and factored it. You could find those, okay. Relative min to max. This was kind of a trick question, so if you didn't catch it, that's okay. There's an inflection point here. You just need to know what it's called. Realize an inflection point basically counts as 2 turns, okay, but it's not a min or a max. All right, this has an absolute minimum here. So if you got that, that's great. But again, that was kind of a trick question I threw at you guys. The big thing for this one is paying attention to real roots and imaginary and how they add up. Okay. All right, so that's how to use a calculator. Hopefully most of that was a review for all these things, but we're putting it together in terms of further analyzing polynomial functions. All right, so we don't need our calculator for the second page. Go ahead and go to the second page, and we're actually just going to look at reviewing factoring. Okay, so all we're doing is factoring. You don't have to solve these. There's no equal sign. You're just factoring. You're just breaking this down, because we're going to go ahead and do this when we get to cubics. Okay, so you're saying, well, Mr. Hilliard, this first one is a cubic. Yes, it is, but you can still use difference of squares to solve it. If you factor out a GCF first, we take that x out, I get 18x squared minus 50. Okay, Mr. Hilliard, still not difference of 2 squares. Excellent point. What could we do to get them to be perfect squares? Divide by 2. Wonderful. So we factor out a 2, and we're left with 9x squared minus 25. Okay, very good. So now, great, Mr. Hilliard, I don't remember what to do now. That's okay. Remember that a squared minus b squared equals a plus b times a minus b. All right, in this case, a squared is 9x squared. So a is 3x. B is 25, or excuse me, b squared is 25, so b is, should be 5, not b, if we substitute. Okay, and then you just change the sign for the next one. And we bring down our 2x, and we are all factored. Okay? Let's do the grouping one first, and you can try the other two. Make sure you're all caught up. So, grouping. So, again, it's a cubic, all right? But what we did with these is if you factor out an x, like we did above, you're left with x squared minus 5x minus 2x plus 10. What we did is we already grouped this. This was a quadratic equation that we went ahead and grouped for you. So you're not worried about that skill right now. Because what you're going to see when you get to polynomials and cubics and quartics is they're already going to be laid out this way. But you can still go ahead and group them. All right. So we're just reviewing this part of the grouping concept. All right, so remember we still have this x out here. I'm going to factor out an x on the inside. I got x minus 5. Factor out a negative 2 from the second part, and I'm left with x minus 5 here. All right, so this completely factored expression is going to be x times x minus 5 times x minus 2. Okay, so as a reminder, always look to factor a GCF if possible. Always try to reduce. It's going to make your life a lot easier before you start factoring. Okay, so try these other two. Try the 27x squared minus 3 and the 3x squared plus 9x plus x plus 3 and factor those. All right, let's take a look at these. So this first one up top. Again, look at the GCF, take out a 3, factor a 3, Remember, it doesn't just go away, especially when you're factoring. If we were solving, we wouldn't need to worry about that 3, but we're just factoring, so this 3 needs to be there to be complete. All right, to be completely factored, we need to leave that 3 right there. Okay? And then you have this last one. Split it up, divide out GCFs, factor out GCFs, and you're left with this. Okay, so as always, make a note of any questions, and we'll see you next time. Thank you.